Welcome to my YouTube channel. Today we will do with the next part of differential equation. Generally we are doing differential equation with variable coefficient. We are in a series to solve the differential equation with variable coefficient, in which firstly we will do Cauchy differential equation. Then we will do Legendre's differential equation, and it is the third part of Legendre's differential equation. In the first part we will see what are the Legendre's differential equation. In the second part we will see how can you solve Legendre's differential equation when it is a homogeneous equation. Now today we will see how can you solve Legendre's differential equation when it is a non-homogeneous differential equation. Now firstly we will see that we will write down this equation in symbolic form. So how can we write down? That is 1 plus x square d square 1 plus x d plus 1 y, that is 2 times sine log 1 plus x. Then what we will do, we will substitute 1 plus x as e raised to power z. So it means that z can be taken as log of 1 plus x. As we know that x plus 1 times d can be taken as theta, 1 plus x square d square can be taken as theta into theta minus 1. Now what is theta? Theta is differential operator, that is d by dz. Now what we will do, we will substitute our each and every value in our equation. So firstly we have 1 plus x square d square, so we will substitute this is theta into theta minus 1, then plus we have 1 plus x into d, it can be substituted by theta plus 1, y is here, then 2 times sine, again we can say it is log of 1 plus x, so it can be substituted as z. So now this is our differential equation. Now we will solve this equation in a further. So we will get here theta square minus theta plus 1 y 2 sine z. So it is theta square plus 1 times y, again 2 sine z. Now we can easily see, to solve this differential equation, we have to find its complete solution. In this case, this differential equation have non-homogeneous, then we have differential equation with non-homogeneous. In this case, we will find complementary function as well as particular integral. Both will give you the complete solution. Now, how can we find complementary function? To find complementary function, first of all, we will write our auxiliary equation. What are auxiliary equation? If we will take coefficient of y is equal to 0, means theta square plus 1 equal to 0. So if I will put theta square plus 1 equal to 0, it means that theta square is minus 1. It means that theta equal to root of minus 1. It means that theta is equal to plus minus iota. So if theta is equal to plus minus iota, so complementary function is of y. What is the value here? It is c1 cos z plus c2 sin z. This is the value of the complementary function. Now we have to find a particular integral. To find particular integral, again we will write an inverse operator. So what is inverse operator? That is 1 by theta square plus 1 is operated on sine z. It's a 2 sine z. Now what we will do here, if we will operate here, that is 1 by theta square plus 1, 2 is here, it's constant, it is only for sine z. Now we have done in our last videos how can we do solve the question, that theta square is replaced by minus alpha square. Minus alpha square means the value of alpha here 1. So theta square is replaced by minus 1. So it means that 2 times minus 1 plus 1 sine z, it means denominator is 0. If denominator is 0 means 1 by 0, this test fails. So if it fails, the next what we will do, we will multiply this by z and we will find its derivative with respect to theta. Again it is operated on sine z. So if we are finding its derivative with respect to theta, it will give you 2 theta here, and if we find derivative with respect to 1, it will give you 0. So again if we will move, it is 2z divided by 2 theta is operated on sine z. So we know that 2 and 2 is cancel out, z here 1 by theta over sine z. 1 by theta over sine z simple means that you will take integration of sine z dz. Now what is the value of integration of sine z dz? It can be taken as minus cos z. Now how can we find complete solution? Its complete or general solution is complementary function plus particular integral. What is our complementary function? If we will see, our complementary function is c1 cos z plus c2 sin z. So it is c1 cos z plus c2 sin z. Then what is the particular integral? Minus z into cos z. So that is minus z into cos z. Again we know that what is the value of z? So the value of z is log 1 plus x. So what we will do here, it is c1 cos log 1 plus x plus c2 sin log 1 plus x minus log 1 plus x, then cos log 1 plus x. So this is the solution. This is the solution of our differential equation, especially differential equation, linear differential equation with variable coefficient. So thank you very much.